Yeah, because you probably grabbed me one.
Alright, so we'll go through the machine here. Alright. 9 times out of 10 when you come into a welding shop, your work is all the way, or the table's all the way on the other side of the shop, and you got to drag the welder out. You got to pull it out off the wall. You're going to take it out. Right? And say I did that, I come and I just come out, I'm in a hurry, and I yank this off, and the bottle's not attached. That's the wall. Right? Say it's not chained up. And it falls off the back. It hits the wall, and it knocks the top off. And I got 4,000 pounds of pressure.
So
It's going to take off like a rock.
someone's died.
Well, maybe. Yeah. So this will go through a block wall. No problem. 8-inch stick. No problem. Okay? So the door's not stopping it, the wall's not stopping it, and none of us are stopping it. It's always, before you even come over to the machine to make sure that it's gone, the first thing you're going to do is turn the gas on. Okay? So the way we do that is we just simply open the freaking valve up to the top, and it's open. Okay, here is my pressure gauge for the volume of the tank and how much pressure is in there now. I've got, I don't know, roughly 500 pounds left in here, so it's been used up almost. Okay. When it's up here around 3,000, this is a time bomb waiting to go off. Right? Still, even with 500 pounds of pressure, it's still going to take off. All right, so don't mess around with these tanks. Second of all, this is your flow gauge. It flows in cubic feet per hour, CFH. Okay, that's how fast the gas flows out is in a cubic foot measurement. So the way this works is I've opened up the tank and now the gas has made it to the diaphragm. But the diaphragm is closed. In order to open the diaphragm, I'm going to tighten this nut down. And as I tighten it down, it's going to push the needle in, and that's going to open the diaphragm, and that's going to let that gas flow through this gauge and then through here. Okay? I'm going to turn this until I get to just between 10 and 15 cubic feet per hour.
I've noticed that a lot of gauges have got 2 lines. Why is that? One, an inner one and an outer one.
So you'll see that on the MIG machine, and you can set these gauges will read strictly argon, or they'll read argon and CO2 mix.
Oh.
If you have a CO2 mix, you use the inside gauge. If you have an argon only, you use the outside gauge.
Oh, okay.
Or whatever it says on the gauge.
So are these gauges strictly for this type of welding? A TIG weld?
MIG or TIG.
Oh, okay.
Yeah, these are universal.
Oh, okay.
But
argon
if you look
only
at the
has one
difference-
gauge.
Argon, see, they're both almost identical. See, this is the gauge that you're thinking about,
Right.
the inside and outside. You can use both.
Okay. So I would
This
go to
one
the
only-
inner side if I was TIG welding.
See how it says CO2 on the outside and it says argon on the inside?
Oh, okay.
So you use the CO2 because there's a
okay.
mixture of CO2 in here. If it's only CO2, you use the outside gauge. If it's only argon, you use the inside gauge. So yeah, there are different gauges, but they all work the same.
This one's CO2.
Just
CO2.
straight argon.
Well, straight argon.
How do I know that?
How do you?
Argon,
Because of the
Where?
color of the tank?
right here.
Because it says argon.
Okay, so both of you are right, but you're wrong, and you're wrong.
Oh, okay.
Okay, so color of the tank. What if this is mine and I paint it pink so everybody knows it's mine?
Oh,
What's in
Yeah,
there?
you don't trust the color of the tank,
Right.
right?
So what do I trust?
what do you trust? The label?
Exactly. What's it say on there? Argon compressed.
Oh,
That's
okay.
all that's in there. If there's CO2 in there, 75% argon, 25% CO2, it'll tell you the mixture. Right? They put these on here, they fill them up,
I see.
trust the label. Straight argon.
Start straight up.
Almost.
Okay, so this is a MIG machine then.
That's the mix.
Okay, got it.
Right? Questions on that? So it's not because somebody put the wrong gauge on your set.
Yeah.
If someone put the wrong gauge on it, it says like helium,
Okay.
and you don't know that. You have to look to
I would hope they'd put the right gauge on
Everybody
there.
hopes, but yeah.
Okay.
Okay. So here we go. Put that to the table, please. All the way on the edge. There we go. Alright, so what is this called right here?
Foot pedal.
It's a foot pedal. Right. And if you listen, hear that? Click. So when I push the pedal down with my foot and it clicks, I'm now sending current through the system. Okay? And as I push this pedal down, I increase the amperage.
Oh, okay.
So if this machine's set at 20 amps, when I start, it starts sending amperage, and as I slowly roll it on, once I finally get to the bottom,
That'll be 20.
that's 20. Anywhere in between is wherever it is in between.
Between 0 and 20.
Between 0 and 20. Okay, so this is how you vary your wattage when you're welding. Amps times volts equals watts.
Amps times volts equals watts.
So I'm sending, this is a constant current machine. So when I set it to 80 amps and I push this thing down, it's sending 80 amps. The voltage is going to change by your movement of your hand. You control the voltage with your hand, you control the amperage with your foot, and you control the feed speed with your other hand. So you got three things going on. So that's why everybody thinks that TIG welding is hard. It's not, it's just coordination.
So the filler rod is the voltage?
No. Your torch, your arc length, which I'll draw for you, distance away from your work with your hand, and your torch, that varies your voltage. Your foot varies your amperage.
Right.
And your feed speed is determined by
Oh, the tungsten tip, the gap.
the gap between the
Yeah,
tungsten
that-
and the metal.
yeah.
That's the length of the arc.
Yeah,
Arc length equals voltage.
voltage, right, okay, all
I'm
right.
not trying to turn this into a physics class, but it's the best way to explain it.
Yeah, I got you.
Okay? So, foot pedal, very sensitive, right? So when you move it around on the ground, you don't put your foot on here and move it, you go like this. Put your foot on here and try and move it, and you accidentally push it down, and you got the torch sitting on your leg, now you're going to zap the shit out of it.
Yeah,
Okay?
yeah.
All right. What's this called?
Torch?
So this is the torch. A few parts to this guy. Everything is hand tight. I'm never going to use pliers on this, okay? I'm just going to take it apart and we'll put it back together. It's all finger tight. This is the box where we keep the extra parts. What I'm going to do is I'm going to see if we have different sizes. I don't like to use this size. Can you find one that says it's got 3/32 seconds stamped on the side here?
Where is it?
There, these little guys. Just dig around in here and find one.
I think it might go to the 3 seconds.
Yeah. See how it's printed
Yeah,
out?
yeah.
So I like using a bigger. Oh, perfect.
For heavier metal?
Yeah, how about another one? See how it's already clamped together? I want to get something that's not
Oh,
clamped
God.
together already. When I teach you guys, I like to use something a little bit bigger, and then by the end of the class, if you want, you can experiment with the little stuff. Unless you don't have something that'll work with.
I'm just mainly interested in motorcycle fab frames and exhaust pipes, like hot rod stuff and chopper stuff, tanks, fenders. That's all I'm going to
use
be
either
using.
side. It's just
No,
up
it's
to
the only
you what
one.
you like to use. Because there's no one way to weld. Right? You weld however you want to. You figure out what works. Nothing left in there.
It's the only one.
Okay, I'll try it. We'll see what happens here. Okay, so we got a few parts here. This is the way it works. So this is your torch, and you're always welding away from yourself. See how this tip is pointing away? If I'm trying to weld like this, I got it upside down. Okay, and you're going to build this thing from the front to the back. Alright, so this is a 3/32 collet holder. And this is a 3/32 collet. Alright, so collet holder and collet. There's a hole in here that's 3/32 in width diameter. That hole's 3/32 in diameter. And I hope that we have a tungsten in here that's 3/32, and this is 3/32 in diameter. So this will slide through here. This will slide through here.
Why are you choosing that size?